This is the ABB system Freelance. We have here the Profibus master module connected in the ASI Profibus DP gateway. This gateway is fed by a third VDC power supply that's used for the ASI network. These two networks are called Channel 1 and Channel 2. They are represented by C1 and C2. The channel 1 is connected to I-VUE sensor and could be connected to more than 61 slaves. In the channel 2, we have other ASI network that is connected to an I/O module. With 2 inputs and 3 outputs. We are going to see the system operating through the logical program in the Freelance system. Here we create a Profibus node using the master Profibus module. Then we create a slave node for the ASI Profibus DP gateway. In the tree of the program, we create 2 channels for the networks C1 and C2. On the channel 1, use the second byte, that is byte 1, for the inputs. In the byte 1, we link the bit 0 to the green button and the byte 1 to the red button. We link bit 0 with the red lamp, bit 1 with the yellow, and bit 2 with the green. In the second network, channel 2, the inputs are in byte 0, and the first 4 bits is for I-VUE status. For the same byte 0, we have the outputs, where bit 0 is for activating the valve. The bit 1 is for self-calibration and bit 3 is for counter reset. We link all these bits with a ladder program. Pressing the green button, we are going to activate the valve. When we press the green button, the I-VUE sensor receives through the ASI network the command to activate the solenoid valve, and the sensor blinks the green LED lights. And through the I/O module, the green lamp turns on, signaling the open valve. If we press the button again, the valve closes and shows the feedback, turning the red lamp on. If we press the self-calibration button, the I-VUE receives the command for calibration. We have to remember to do this, we need to press the button, wait 3 seconds and release it to start the auto-calibration. By pressing the green button, we activate and deactivate the valve connected to the I-VUE sensor. It's possible to reset the counter by activating the bit 1. This bit is activated by a logical memory. We activate the bit from 0 to 1 for at least 3 seconds, and after that we deactivate the bit from 1 to 0. Let's now simulate a defect in which the I-VUE is going to signal the occurrence of some problem by indicating the anomaly through the yellow signaler lamp. As an example, we generated the solenoid actuation defect by switching off the air block valve that interrupts the airflow to the actuator. After some seconds, the I-VUE detects that there are no actuation of the solenoid and indicates the defect through the yellow signaler lamp. If the block valve is switched on, the solenoid returns to pressurizing the actuator, and the defect signaling disappears from the I-VUE, which indicates again the valve position.